When this probe set off on its journey in 1977, no one thought it would still be sending data more than 45 years later. Voyager 1 has just sent a disturbing message from an unknown star in the interstellar medium. NASA is worried and fears for the safety of the probe. Will Voyager 1 continue its journey and eventually arrive at a distant star as humanity's first messenger? Or is it all over now? Voyager 1 is a technical wonder and an icon of space travel. Launched in a rush in the 1970s, this probe and its twin Voyager 2 have now been flying through space for more than 45 years. Their primary mission took Voyager 1 and 2 to the outer gas and ice planets. After that, there was hope that the two might still reach the edge of the solar system. They managed that too, and Voyager 1 and 2 have now been in interstellar space for more than 12 years, sending measurement data to Earth for the first time. Humanity owes so much to these two probes that the idea of living without them is not only difficult for NASA. The fact is that Voyager 1 and 2 will eventually run out of power. With any luck, the radionuclide batteries will continue to supply sufficient power for the long radio transmission into the 2030s. In the meantime, the probes are so far away from Earth that a signal takes more than 22 hours to reach home. One day in the fall of 2023, everything suddenly changed. Voyager 1 sent a confusing combination of ones and zeros that made no sense. The cryptic message had to be decoded. Voyager 1 had already sent highly peculiar data from the interstellar medium to Earth twice before. Shortly after crossing into this largely empty space between the stars, the probe reported a mysterious plasma stream that should not actually exist there. Within the heliosphere, we still have around 100 particles per cubic centimeter outside the envelope of our solar sphere. Scientists suspected only one particle in the same space. But on the one hand, Voyager 1 reported a fundamentally higher particle density than assumed. And on one particularly memorable day, the probe even recorded a veritable stream of particles. Plasma in the interstellar medium, where nothing should actually exist, is a mystery. Scientists therefore also suspected that the plasma could be a measurement error. Others were of the opinion that there may be more going on in the void of the cosmos than we previously thought. The third explanation was a stellar flare that somehow made it into the vacuum of space. This would mean that signals from stars can travel through the interstellar medium after all, but that would be rather unusual. The flares from our own sun only travel as far as the end of the heliosphere, which is about 100 astronomical units or 15 billion kilometers from the center of the solar system. Large streams of particles usually reach the threshold of interstellar space within a few hours. Since Voyager studied this area of the solar system, we have known that the streams of particles from the Sun meet the interstellar medium there, and the pressure that the two exert on each other creates something like a thick shell. Without this important protection, the extreme radiation of open space would penetrate unhindered into the interior of the solar system, and life on Earth would probably not be possible at all. So not only do we have our sun to thank for warmth and light, our star also safely and reliably envelopes us in a protective cosmic mantle. However, as the Voyager probes have shown us, the sun's plasma streams do not penetrate into interstellar space. They end strictly at the end of the heliosphere. So let's assume that the scientists are right when they say that the plasma stream came from another star. In that case, we have to realize that even the nearest star, Proxima Centauri, is more than 4 light-years away. This would mean that the plasma stream has traveled through the interstellar medium for more than 4 years, which is not possible. The plasma streams should actually be lost due to the low particle density in free space. If a current remains or makes it to the vicinity of our heliosphere, this current either originates from a nearby source or is driven by a very strong force. Whether the mysterious signal really comes from a star or a previously unknown natural force in the interstellar medium is still unclear. We would need further measurement data and observations to come to definite conclusions. This scientific surprise was followed by a shock. Voyager 1 suddenly sent such confusing data in 2021 that scientists thought the probe had lost its orientation in space. The error was corrected within a few weeks. the scientists discovered that the probe's telemetry data had shifted, making it appear as if the probe was tumbling uncontrollably in space. A system change brought relief, and Voyager 1 continued its grandiose flight through space. Voyager 1's unique journey, something that many people don't realize, is that NASA wasn't at all sure that Voyager 1 would ever even reach its first destination, Jupiter. The probe took a course that was considered difficult and risky by experts at the time. It took a direct route through the asteroid belt between Jupiter and Mars, while Voyager 2 chose a slightly different route and performed several acceleration maneuvers at various planets. Their route was considered safer, and the two probes had been specially constructed so that they would have another one in case one of them was lost. In the 1970s, a constellation of the outer planets took place that only occurs once every 176 years. NASA had to take advantage of this, and at least one probe was to reach the outer reaches of the solar system. The world was lucky because both probes arrived exactly where the scientists wanted them to be. In March 1979, and only 18 months after launch, Voyager 1 was already at Jupiter. That was sensational. During its approach and flyby, it provided breathtaking images and valuable data of Jupiter's turbulent atmospheric currents and powerful storms. It photographed the red spot and the colorful cloud bands. Io, Jupiter's moon, had long been known at the time. As one of the largest moons in the solar system, Io was already visible with fairly simple telescopes in the late Middle Ages. What was completely new in the 1970s, however, was the discovery of volcanic activity on the moon. Nobody had expected to see sulfurous volcanic eruptions shooting kilometers into space on a moon. It was the first direct observation of geological processes on another body in the solar system, and thus a milestone in planetary research. While Voyager 1 was making all these fantastic discoveries, Voyager 2 was already on its way. It reached Jupiter in July 1979 and initially confirmed many of the discoveries made by Voyager 1. In addition, there were further surprises and detailed observations of the rings and numerous moons of the gas giant. The two probes worked hand in hand to complete our understanding of the largest planet in our solar system and its moons. After the successful flyby of Jupiter, Voyager 1 continued its journey and reached Saturn in November 1980. Where it was the first to photograph the planet's rings up close, finding evidence of complex structures within the rings and observing Saturn's atmosphere and magnetic field. Special attention was paid to Titan, Saturn's largest moon, whose dense foggy atmosphere triggered speculation about a possible resemblance to Earth. Here too, the two probes worked together brilliantly. Voyager 2 reached Saturn in August 1981 and supplemented the studies on Saturn. Among other things, its data served to clarify questions that had arisen after Voyager 1's visit. Voyager 2 then continued its mission by flying on to Uranus and Neptune, while Voyager 1 embarked on an orbit that would take it directly to the end of the solar system. A particularly memorable moment in Voyager 1's mission was when the image of the pale blue that was taken. This image gives the impression that the most successful and furthest traveled probe of all time is looking back at its starting point, Earth. Our blue home appears in the picture as a tiny, fragile blue in the vast ocean of space. And yet, the probe was only around 6 billion kilometers away from Earth in 1990, the year the picture was taken. In cosmic terms, that is a stone's throw. But for us, it was a milestone. This image shows us how insignificant our planet is in the vastness of the universe. It's not much more than a grain of sand on a beach. And yet our world is so rich and so beautiful. The picture was taken at the suggestion of Carl Sagan. Sagan was an astronomer who spent his life pointing out what a unique treasure our little world is. Finally, in August 2012, Voyager 1 became the first man-made object to cross the threshold into the interstellar medium, leaving our solar neighborhood and entering a region where the influences of the Sun are gradually being eclipsed by the influences of the galaxy as a whole. Voyager 1 provided almost 12 years of invaluable data. But then something happened again that now very probably means the end of the probe. A sad farewell to Voyager 1. NASA had wanted to avoid this. All the technicians, scientists, and control staff were proud and happy when the telemetry problem was successfully resolved in 2021. When the next shock came in the fall of 2023, everyone was initially optimistic. Voyager 1 was transmitting a jumble of ones and zeros, and the data no longer made sense. A technician from the Deep Space Network, through which Voyager 1 communicates with Earth, decoded the message as an imprint of the internal storage system, where a simple computer records all the probe's data and movements. The database could be described as a kind of universal logbook, and at the same time, it also contains the complete control of the probe. The probe is therefore still alive and probably largely functional. Only the transmission of the data no longer works. Unfortunately, the problem turned out to be difficult this time. So far, NASA has not found a solution and is very skeptical that the problem can be solved. Now we have to expect the worst, and the Voyager 1 mission may now be over, at least as far as our communication with it is concerned. The probe will continue to fly, but we will no longer be able to track it. In many thousands of years, the probe will reach the nearest star. And who knows, maybe someone will find it there. Both Voyager probes have a golden record on board, which should be playable by any reasonably technologized civilization. Anyone who finds Voyager 1 one day will be able to hear sounds from our Earth, birdsong, children's laughter, and the noise of our big cities. Subscribe to the channel now and be part of every new video highlight.